So for chapter 1, section 2, we're going to talk about functions and graphs. And what I really want to do is just remind you what certain functions look like and how they can move. We're going to talk about vertical and horizontal shifts, reflections, stretches and shrinks, piecewise functions. Okay? So there are 6 basic functions that you should be able to know. Identity function, square function, cube function, square root function, cube root function, absolute value function. And I just want to point them out. So the very first function, if you have a plain old x, not x squared, not square root, nothing special, just a plain old x, a number in front, adding or subtracting a number, dividing whatever, but a plain old x, that's linear. That's going to give you a line, okay? This function here has a y-intercept of 0, a positive slope, it's going upward. But if you have a plain old x, it's going to be linear. Plain old x, linear. And the domain is all of these. If you have x squared, what's that going to look like? That's going to be your parabola, okay? The little things we should know, and we'll talk about in a minute, but x squared is a parabola, if that's your highest power. If the number in front is positive, happy face. Number in front negative, sad face. All the other parts are going to make it move up, down, left, right, wide, narrow. We'll talk about all that. But x squared is a parabola. X squared is a parabola. The domain is all reals in the range is 0 to infinity on this. If you have cubic as your highest power, does anybody know the name of that one? It's not a parabola. Hyperbola. Okay? It has this sort of like S shape. Now again, x cubed, that's the basic shape. It could be flipped, it could be wider, it could be shifted, but the basic shape of x squared is a hyperbola. Hyperbola. There's a cool little cartoon where they have all the little shapes as dances. Square root function kind of looks like an arm jetting out, okay? Remember the special thing about square root is, can you take a square root of a negative? No, so only whatever makes that inside, the radicand positive, is what works. So all these numbers work. That's why it starts here and shoots out, has a gradual, but the shape of a square root of x looks like that.
What's it called again?
I'm not sure the exact name, but it just has that shape. Because after a while, it's like a square root shape, right? That's the shape of the square root function.
Okay.
Cube root kind of looks like a hyperbola, but it's on its side. Has that shape. So basically, when you see that, you know what the shape will be. When you see that, you'll know what the shape will be. Absolute value has a V shape. Absolute value has a V shape. Absolute value has a V shape. And again, go up, down, wide, narrow. When you see absolute value, those are the shapes. Now, as I was mentioning, they have a little cartoon that kind of goes over these shapes. So they say this is how a mathematician dances. This is the math function dance. So the ones that we went over, if it's a plain old x, x squared, cube, absolute value, okay? Those are the basic shapes. Absolute value positive, absolute value negative, negative x, and some other shapes in it, okay? Vertical and horizontal shifts. Remember the idea is that vertical is up and down, horizontal is left and right. So the way it works is if you have your function and you add something on the outside, that makes it a vertical shift. You can add it, go up, subtract it to go down. So on the outside, that does the vertical shift. If you add or subtract on the inside of the function, that's a horizontal shift. The part that people get confused on with the vertical shift, on the outside of the function, if you add, it goes up, subtract, it goes down. But on the inside, the horizontal, if you add, it actually moves it to the left. Subtract, it moves it to the right. And the way I like to remember it is, if you add something to it, you think it would go to the right, but you got to make it 0. So you actually go to the left. Okay? But basically, out of it, vertical up and down, inside, horizontal, left and right. So an example of vertical shifting is, there's our absolute value, original function. If I add 4, what's that function going to do? It's going to go up 4. Okay? There's our function again. If I subtract 5, what's going to happen? It's going to go down 5. Now, horizontal again is left and right, so there's our absolute value function. If I add 4 to the inside, is it going to go up or down, left and right? Left to right. But when you add 4, you actually go to the left. 4. Okay? Again, absolute value function. If I subtract 5, it's going to go to the right 5. All this can be done in your calculator to practice. So again, vertical, up and down, horizontal, left and right. As far as stretches, shrinks, and reflections, this is when we multiply the function by a number. If the number we multiply is greater than 1, we have a vertical stretch. And I'll show you examples of that. If the number is between 1 and 0, we have a vertical shrink. Now again, a way to think about this is that a number greater than 1, like times 2, you're doubling it, right? So that would be a stretch. Between 0 and 1, what do you have? You have fractions, a half, 3/4, 1/4. That will make it shrink. That will make it shrink. And again, we'll look at examples. And negative makes it a reflection. It makes it flip. So here's our absolute value function. And if I multiply by 2, notice what happens. Now again, you're seeing that it got smaller. That's a way to look at it, but it's actually a vertical stretch, because is it growing faster or growing slower if I multiply by 2? It's growing faster, it's doubling. That's why it's steeper, not as flat, because it's growing faster. That's called a stretch, If I multiply by a half, now we're shrinking. Is it growing faster or is it growing slower? It's growing slower. That's why it's wider. The word shrink could throw you off. But think about it. Multiplying by a half, it's not growing as much. It's going to be not as steep. It's wider. Okay? And then when we talk about reflections, there's your original absolute value function. If I multiply by -2, 2 is going to make it steeper or wider? Steeper, growing faster, but the negative is going to make it reflect. So instead of going upwards, it's now going downward and steeper. Okay? So the negative is what made it flip. The -2 is what made it steeper. So in summary, the stretch is greater than 1. Shrink is between 0 and 1. The reflection is when we have a negative. So in these examples, you'll notice we moved it over to the right 3, but the negative kind of flipped it to reflect on the other side. So negative makes reflection. So we're reflecting about the y-axis. So the negative on the outside reflects about the x-axis. The negative on the inside reflects on the y-axis. What does that mean? Here's the x-axis. If the negative's on the outside, it reflects over the x. If the negative's on the inside, it reflects over the y. And again, things you've seen before, my advice is always to use the calculator and graph it. The last thing we're going to talk about in the last couple of minutes is piecewise functions. The bottom line is, it looks like one graph one way, it looks like another graph another way. So what I mean is, we have, it looks like negative x when x is less than 0. It looks like x when it's greater than or equal to 0. So let me just give you a quick example and we'll stop there. So when x is between 0 and 2, it looks like x plus 1. Between 0 and 2, the graph looks like x plus 1. Notice it doesn't include 2, so what do we have? Open circle. Anything greater than 2, it looks like 0.5x. It includes 2, so the circle's filled in. So real quick, piecewise, between 0 and 2, it looks like this. Includes 0, filled in. Doesn't include 2, open circle. Anything after 2, it looks like 0.5x. Includes 2 and keeps going. So piecewise function basically means it looks like something in one area, but it could be a different graph in another. Okay? And we'll stop there. Okay, we made it. All right, I'm going to take attendance real quick.